Science tells us that our universe started out with an enormous explosion about 14 billion Earth years back. Since that time, the billions of galaxies, each composed of billions of stars like our Sun, are still moving outward at enormous speeds. The Big Bang event initiated the whole universe from a state of apparently zero volume and apparently infinite energy. From that instant of creation, time began. Over the following 14 billion or more years of our human timescale, that initial fireball of energy evolved to produce the vastness of the universe. At this stage in scientific discovery, we know that this vastness contains about 100 billion galaxies, each made up of thousands of millions of flaming stars like our own Sun. The picture shows just a tiny section of the universe. Evidence for the Big Bang creation resulted from observations that the universe is expanding. In addition, the galaxies that are furthest away are moving away the fastest. The Hubble telescope has revealed that the most distant galaxies are receding from us at rates directly proportional to their distance. This suggests that our universe started small and then expanded. In addition, we have detected the leftover heat from this explosion in the form of the microwave background radiation. This is the same no matter where we look in the universe. Another support for the Big Bang origin is the observed cosmic abundance of helium. In the Bible book of Psalms, King David looked up at the starry sky and proclaimed, "The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they display knowledge." However, David lived long before telescopes were invented, and so he could only see about 8,000 stars. Now, with the aid of amazing telescopes, such as the orbiting Hubble telescope, we can see that many dots of light that we originally thought were stars are actually whole galaxies. Here we see just one galaxy called Andromeda, with another one next to it that looks much smaller because it is much further away. The fact that galaxies look hazy in our telescopes is because they are far away. In this one galaxy, we are actually looking at about 250 billion stars like our Sun. We cannot see the whole of our own galaxy because we are in it. However, we know that ours is a spiral galaxy, rather like this galaxy called M81. It is 12 million light years away from us in the Ursa Major constellation. We call our galaxy the Milky Way, and it contains about 250 billion stars, like our Sun. Our Earth and Sun are situated near the edge of our galaxy, as indicated by the marker on the picture. If we look with our powerful telescopes at stars on the other side of our own galaxy, we find that they are about 100,000 light years away. In other words, light from stars on the other side of our galaxy has been hurtling through space towards us for 100,000 Earth years. But we may ask, how reliable are various scientific estimates of distances to faraway galaxies? Initially, astronomers had to use indirect methods for estimating distances to other galaxies, and various assumptions had to be made, such as that the faintness of a light source is a measure of its distance away from us. Physics has demonstrated that a doubling of the distance reduces brightness by a factor of 4. Such techniques have been used to estimate distances of stars up to 25,000 light years away. Then, in 1929, Edwin Hubble discovered that the redshift in light coming from distant galaxies is proportional to their distance. Calculations based on this observation have been used to obtain approximate distances to galaxies up to some 12 billion light years away. However, these measurements always relied on certain assumptions. The next big advance came with the use of radio telescopes. Radio astronomers have now measured a distance of 23.5 million light years to a galaxy they have called NGC 4258. One radio astronomer pointed out that ours is a direct measurement using geometry and is independent of all other methods of determining cosmic distances. For astronomers, this measurement is like a golden meter stick in a glass case. These refinements, enabled by radio astronomy, have caused adjustments to previous calculations of very distant galaxies. For instance, prior to the radio astronomy measurements of NGC's distance, other measurement techniques suggested this galaxy was between 27 and 29 million light-years away. The updated measurement gives a slightly smaller distance of 23.5 million light-years. These sorts of refinements are bound to happen each time astronomical techniques are improved. However, although this more accurate measurement shows that previous ones were overestimates, the fact remains that far-off galaxies are many billions of light-years away. The nearest star to our own Sun is called Alpha Centauri, and it is 4.37 light-years away. This means it is over 40 trillion kilometers away. Even with light traveling at 300,000 kilometers each second, it still takes over 4 Earth years for light to reach us from this nearest star. We can start to realize that just to fit 250 billion stars into our own Milky Way galaxy has to take up an enormous space. Then consider that there are normally hundreds of thousands of light years between galaxies and at least 100 billion galaxies. In other words, even if some of our estimates of distance are a bit out, the universe is still enormous and has a radius measured in billions of light years.